Hey guys, welcome back to the channel. So in one of our previous playlists, we learned how text is split into tokens using different tokenization techniques. But after tokenization, another important question arises. How does the computer actually represent these words? After all, computers can't actually understand text and they need numbers for that. So in this new playlist, we will look at different techniques used to convert text into numerical vectors, starting with two of the simplest ones, that is one-hot encoding and bag of words. So let's once quickly recall tokenization. So suppose we have a sentence like I love NLP. And after tokenization, for example, we took word-based tokenization, we get the tokens I love and NLP. But these are still just words. A model cannot directly work with text. It needs numbers as an input. So our next task is to convert these words into numerical vectors. The simplest way to do this is known as one-hot encoding. So it was one of the earliest techniques used to represent words numerically. So the first step in this was to build a unique vocabulary containing all the words uniquely occurring in the dataset. Then each word is assigned a unique index. Finally, every word is represented as a binary vector whose length is equal to vocabulary size, and only the position corresponding to the word is set to 1, while every other position is 0. That's why it's called one-hot encoding. So here let's take an example. Suppose we have a sentence, I love NLP AI. So here we represent each of the word in the following way. As you can see, the one of the place is 1, which is the index assigned that particular word. And the remaining all the positions are 0. Hope it's pretty clear. So here are a few advantages and limitations of one-hot encoding. So the advantages are it's pretty simple to understand and implement. And also it works pretty well with vocabularies which have small size and a limited number of unique words. Though the limitations are that there is no sense of capturing of meaning. So for example, you have words like car and automobile. Even though they are pretty similar, but they can be very far apart from each other in this representation. And second is, if suppose we have a very large vocabulary, then most of our vectors would be very sparse and will contain very little information, and they would be very long, making them like highly memory consuming and inefficient. So, even though one-hot encoding worked decently well for small vocabularies, it wasn't able to capture the word frequencies. Like suppose a word like love occurred 4 to 5 times in dictionary, it won't capture. So for that, there was introduction of a new technique known as bag of words. So the pipeline for this was pretty simple. So we initially built our vocabulary with collecting all the unique words occurring across our data set. Then we counted the occurrence of each of these, and then we represented this document using each word along with the frequency of its occurrence. So the key idea behind bag of words was that how many times a word appears and not actually where it was appearing. So this method used to work pretty well for tasks such as sentiment analysis, because, for example, we have a sentence with a negative sentiment. It would have a lot of words like bad, words, and as bag of words is able to capture the frequency, it would used to work pretty well in such tasks. So let's see an example of bag of words. So suppose we have the following sentence, I love and I love AI. So it captures the unique words in the vocabulary of the document and also the frequency count, as you can see in this example. So here, let's look at a few examples of this. So the first is obviously along with one-hot encoding, it's also pretty easy and simple to implement. And it works pretty well for basic tasks, as I just discussed previously, that it works pretty well for text classification, spam detection, and sentiment analysis. But the limitation is that it ignores word order and context. So for example, a dog bites man and man bites dog. Both of these would have similar representation. And just like one-hot encoding, it also doesn't actually understand word meaning. As similar words like car and automobile are treated as completely separate words. So that's going to be it for the first video of our this playlist. Today we learned about one-hot encoding and bag of words along with their advantages and limitations. If you guys enjoyed it, make sure to like and subscribe and let me know I can improve my videos in comments in future. Thank you guys.